magic is 3 months out. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 22nd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Seasonal Nudge, Beat on Ian, DL Man, Mont the Drifter, Ken Antel, Tim Caston, and the big contributors for the week, Eastlate and Coach Nate. Thank you all so much. I really appreciate it. It does help keep the channel going. And with that, let's get to work. I'll start by looking at significant wave heights around the planet, starting in the North Pacific. A little bit of a gale pushing off of North Japan here with about 25-foot seas aimed off to the east. May be good for producing a little bit of swell for the Hawaiian Islands, but that's probably about it. And by little, I mean very little. In the South Pacific, literally nothing going on. The star of the show, again, has been the case pretty much this entire winter. The North Atlantic with a gale with 41.8-foot seas. These are the highest seas over this entire domain. Here's their position coordinates and max wind speeds, 56.1 knots. Also their location and direction. Already impacting, I guess this would be Norway and that area, blowing past Ireland and most of Europe now. In the South Atlantic, pretty quiet pattern, 22-foot seas south of South Africa, and sort of the same status for the Indian Ocean, a little gale with 22-foot seas, but of no real concern. But before we get into all that, we're going to take a look at current conditions. We're going to use the buoys. We're going to start up in the Pacific Northwest, the Grays Harbor Buoy 036. They're right on the border between Oregon and Washington. We're looking at all the energy that's hitting that buoy, all the way up from 33.3 second period, very long energetic swell, if there were any, 0.0 feet, the whole way down to 5 second period, just pure unrideable wind chop at 0.7 feet. Most energy here somewhere between about the 11 and 9.9 second period range. It is not any one frequency here that defines a swell, but is the sum of energy on the shoulder of the peak plus the energy the peak that kind of defines the swell. Let's see how well the algorithm does. Primary swell 7 feet at 10.5 seconds from 283 degrees, making surf at 7.4 feet. That's pure, pretty much wind swell, with some secondary wind swell in the mix, 4 feet at 7 seconds from 281 degrees, theoretically adding a 2.8 feet of basic chop or very short period wind swell in the mix. Down to Northern California, the Point Reyes Buoy 029, they're off of Point Reyes just north of San Francisco. Pretty much the same sort of pattern. Wind swell in the 9 second period range, and then there's some sense of something way out here, but I don't know whether that's real or more just like an anomaly. Sometimes you got to look at these charts every half hour. That's how often they update, and you can see what's real and kind of get a sense of what's real and what's not. Anyway, primary swell again, 7 feet, 9.8 seconds from 322 degrees, making surf 6.8 feet, and virtually no secondary swell. Down to Southern California, the Point Loma South Buoy 191, they're off of San Diego. A little bit more energy here. Background southern hemi swell, or really kind of fading southern hemi swell. There's been a good run of surf pretty much all week coming from the south. Now you can see there's like 1 foot at 14 seconds and 0.9 feet at 12 to 13 seconds. So let's see what we have. Primary swell 1.8 feet, 13.2 seconds from 211 degrees, making surf 2.4 feet. Yeah, top spots there were chest to shoulder high sets today, and it was still rideable and fun in Southern California. With secondary swell, that's probably northwest wind swell wrapping around Point Conception, 1.7 feet at 10.2 seconds from 262 degrees, adding 1.8 feet of some energy into the mix. And then finally, last stop, over to the north shore of Oahu. We're using the Honolulu buoy over on Kauai, number 202, because the Waimea Bay buoy is down, but at this point in the season, it just doesn't look like it's really even going to make much of a difference. We have a good spectrum of energy here from 5 seconds all the way up to 18 seconds. There is some swell coming in from a previous gale off of Japan into Kauai, and I assume the north shore of Oahu, mixed with a bunch of north wind swell in the mix. Let's see how it goes. Primary swell 5.4 feet at 11.5 seconds from 57 degrees. So that's even northeast, making surf 6.2 feet. That's maybe a little bit bigger than what it looked like earlier this morning. With secondary swell 2.6 feet at 14.7 seconds from 298 degrees. The more rideable swell, putting it at, like chest high, 3.8 feet. All right, so let's do a retrospective, a Hindcast. Let's go see what has been going on for the past week, since last week's video. We're going to start in the North Pacific. We're looking at significant wave heights. Yeah, a bit of a gale was there north of Hawaii, another one off of Japan. Not really doing a whole lot. It did redevelop on Monday with, about 24-foot seas, and I thought it built to like 26 feet. Yeah, there we go, 26.2 feet. Aimed a little bit west of the Hawaiian Islands, but swell still did result for the Hawaiian Islands. After that, here's one gale developed off of North Japan, sending minor swell towards Hawaii. I think that swell is hitting, that's what we're seeing hitting today. And then after that, here's the next one starting to develop on Saturday with up to 26-foot seas aimed off to the east. So that one will be pushing off towards the Hawaiian Islands. It's not, we're talking very minor swell and literally nothing for California. And that gets us to current time. Then looking in the South Pacific, I'm actually going to rewind this a bit because there was this gale that pushed south of Tasmania on Friday into Saturday with like 32, 31-foot seas. Some swell, I think, has creeped up in between Australia and New Zealand, filtered by Fiji, bound in for the Hawaiian Islands in time. I think it's actually already hitting. And then after that, though, a pretty quiet pattern set up. We're into Thursday. Little tiny gale here. I don't know that any swell is necessarily going to result from that. Seas 26 feet, pretty long distance. Who knows? Maybe some background swell will result, but I'm not very confident on that. And there we are, current time. So all in all, pretty quiet pattern for the South Pacific. Again, as intimated earlier, the North Atlantic has been the star of the show a week ago on the 15th, 43-foot seas, taking aim on Ireland and Scotland. That passed by. Another system, let's go back there, with 35-foot seas, took aim on Portugal and the Bay of Biscay, recirculating off the coast of Morocco. There's another gale impacting Iceland, still 30-plus foot seas in that area. We're into Saturday, yet another gale behind that you see pushing towards Norway, and that is current time. To the South Atlantic, a little bit early in the season still, there was a little gale with 24-foot seas targeting South Africa on Monday into Tuesday, the 17th of March. After that, let's see what we had. Friday, Saturday, really not a whole lot. I'll call it 18, 19-foot seas south of South Africa today. There we go, building 22 foot. So some swell should result. You see the leading edge of the swell front about a day out from South Africa. And finally to the Indian Ocean, kind of quiet. We'll see how this plays out. 26-foot seas south of Australia. Tropical system in the mix there Thursday. And actually kind of held together pretty well there Saturday, Sunday, but all in all, here we are, current time, pretty quiet, not a whole lot going on. So next up, we're going to do a deep dive. We're going to look at the North Pacific. One might say, well, why the South Pacific versus the North Pacific? Well, typically this time of year, Still, we'd be very interested in the North Pacific. This year is a bit of an anomaly, not a whole lot going on, but they're really, I'll just let the cat out of the bag. Nothing really is happening down south, so we'll do the North Pacific. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push into the jet, a push in the jet to the south. You see a bit of it there, that southward push. That in turn helps create a counterclockwise flow aloft. That's the hallmark of low pressure. That also manifests itself down at the ocean surface. And if the low is deep enough, it produces winds. Those winds get traction on the ocean surface, generate seas. As the seas radiate away from the fetch area, the lesser period elements decay away, exposing longer period swell. Of course, swell when it hits your beach like Hawaii there or California there, you get surf. So we have the weakest of weak troughs here off the Kuril Islands, but notice that the jet is split and it is weak. You really want to see 150 knot winds minimum, and what are we at here? 120 knots if you're lucky, and split. And then the jet really splits over the date line. When you get this split pattern, all you end up doing is getting high pressure underneath. That has been the hallmark of pretty much what's been going on since sometime in mid-February, at least, if not earlier. Now, the jet finally does consolidate, pushing into the Pacific Northwest, rain and weather up there. California still, though high and dry. Again, that rising sort of thing suggests a clockwise pattern aloft, high pressure. And then, of course, in fact, someone just commented in the comments, is the blob in effect off of California, and is that having an impact on rain? And the answer is absolutely yes. The blob is just high pressure, strong high pressure. Why do we have strong high pressure? Well, this year has been a La Nina year. Probably the best way to see it, not looking at all getting way down in the weeds, is when the North Atlantic is happening and the North Pacific is asleep for months on end. That is your best indicator, and that's where we are. In fact, the week before, somebody commented, someone that lives in Ireland said it's been like the best winter they've seen in years. So, again, just more icing on the cake. La Nina in control of the Pacific. All right, so let's put the jet in motion, see what we have into Monday. Same sort of deal, the split pattern. Look at this, building the whole way up into the Bering Sea. We've seen so much of that lately. It's just kind of miserable. Now, here we have a little bit of a trough forecast off the Pacific Northwest on Tuesday. Maybe that'll help, but notice the jet getting even more split off of Japan over the date line, not doing anything, and even more split as we get into Wednesday, Thursday, the 26th of March, and you can see where this is going. Some of this is springtime setting up, but March, if it was a good year, if it was a El Nino year, you'd have piles of energy being dumped into the jet. The jet would be doing its thing. The North Atlantic would be quiet, and the North Pacific would be firing. But no, we are just suffering. And the thing is, all the forecasts were suggesting weak La Nina, kind of a neutral, if even neutral, over the Pacific. But no, what we've ended up with, again, don't necessarily trust the models, is La Nina. It's manifesting itself in the atmosphere, or expressing itself, I think is a better way. That's sort of like genomic talk there. But the La Nina pattern is expressing itself in the atmosphere quite well over the Pacific, with just massive splitness in the jet. Attributable to nothing other than all the energy's over in the Pacific. There isn't energy. Over in the Atlantic, there's no energy in the Pacific. The jet gets weak. It splits. It meanders. Now look at this. About a week out, there is this 140 knot winds, a bit of a trough. So maybe there's some hope for some sort of a gale. But that just showed up on the models. Literally, this run, the 18Z run of the models this morning when I was doing forecasts, it wasn't there. So who knows? I don't believe it. We'll just have to wait and see. All right, let's go down to the surface. In the end, at the end of the day, it takes wind blowing on the ocean surface, imparting energy into the ocean in the form of like wind waves. That fetch, if it blows over a long enough period of time, over a broad enough area and is aimed at you and sort of starts moving at you, that energy generates seas that then, of course, are pushing in your direction, make swell. So we have a little bit of a gale here off the Kuril Islands, North Japan, 35 knot winds. That's good enough for maybe 13-second period swell. Targeting Hawaii somewhat. Other than that, really nothing. That guy fades out completely. We get into Monday and Tuesday, the 24th of March. A little bit of a low pressures here, forecast developing off of Oregon up into Washington. We'll have to keep our eyes on. There is a tiny little area of 45 knot winds in the northwest quadrant targeting California, but I'm not holding much hope on that. 35 knot winds again in a new low off Japan, lifting off to the north. You see the low there trying to push in at Tuesday into the Pacific Northwest. Most of the fetch in this gale off the Kuril Islands is in the northeast quadrant, aimed back at the Kuril Islands, not so much at Hawaii, but there you go. You get a little bit of a fetch eventually as we get into Wednesday targeting the Hawaiian Islands. So maybe, just maybe, there's some hope there. You didn't want to see that, but look at that, nuking northwest winds off the California coast. We'll get into that later on in the presentation. Now, here is that trough and supposed gale on Saturday, 35 to 40 knot to 45 knot northwest winds. That looks like, sort of more typical of what you'd see this time of year. Another gale off Japan as well. Whether any of this materializes, I don't know. The models have been really struggling more than a few days out, so I'm not going to hold a whole lot of hope out on any of this, but it sure would be nice. We need some semi-legit swell, at least, into California and the Hawaiian Islands. What is the effect of those winds on the ocean surface? Ultimately, you have to have seas. The wind has to get traction on the ocean surface, generate seas of minimum 25 feet to really, produce like, let's say, 14 or 15-second period swell. Anyway, here's our little gale off the Kuril Islands, 23 or 4 foot seas, really of no interest. Here's the next gale. You see the wind. We saw the wind model, but where the seas are, really all targeting Vancouver Island. I'd say swell into Washington, maybe sideband energy down into Oregon, but probably nothing for California. Another gale off the Kuril Islands on Wednesday, Thursday, maybe producing something relative to Hawaii. And then we have our gale on Saturday, the 28th of March, developing 25-foot seas, maybe some sideband, I'll call it northeast swell for the Hawaiian Islands, but this looks more to be targeting north and central California. There you go, 29.7 foot seas. Yep, that's the peak of it on Saturday night, fading to 27 feet. That all looks beautiful if it were to happen. Another gale off of Japan on Sunday, the 29th of March, doing the same sort of thing, just this steady dribble of like 14, 15-second period background swell in the waist to chest high range or something like that relative to the Hawaiian Islands. But let's go take a quick scan at some other locations around the planet. We're going to look at all the oceans of our planet. We're going to start here in the South Pacific now. Theoretically, somewhere here we go on Saturday, there's this gale forecast developing in the very deep southeast Pacific. There is this other gale here targeting Peru and Chile outside of the California swell window. Southern California, San Diego is like 118 west, so a line right along there. Here we go. Saturday, 28th of March, 29-foot seas building to 30 feet. Just about that, and then moving out of the swell window. So we'll see how this plays out. This is still almost a week out from forming. But it continues on targeting Chile and Peru. Where are you? 168, 180 hours out. So potential for South America, Central America, Mexico for sure. And with luck, California, probably focused on Southern California. In stark contrast to the Pacific, we go to the Atlantic, and here we go, boom, right off the bat. 38-foot seas on Monday, forecast, pushing right into or just north of Ireland yet again. Just non-stop swell machine. Secondary swell pushing into Scotland and Ireland area. Then here we go, another gale on Wednesday into Thursday, seas in the, what was that, 39-foot range. More pushing up towards Iceland, so indirect energy for exposed breaks in Europe. And then here we go, 41 feet, 48 feet, 51-foot seas. Now again, this is more like almost a week out, so I don't know if I believe it. Pretty fair distance away from Europe. Oh, and 53-foot. Lots of swell energy. Again, this area right in here, just a total bullseye. And then even up in there, you see this into Sunday, it's 49-foot seas. All the energy clearly focused on this portion of our planet, totally bypassing the Pacific north and south. To the South Atlantic, looking for 25, oh, there we go, 33-foot seas south of South Africa, aimed off pretty well to the east, maybe sideband energy radiating north. We'll see if it actually does that. You get the sense, yes, for sure something will happen relative to South Africa. I'll call it more sideband swell, though, than anything. We're into Saturday now. Sunday, we're a week out. That was it, the only hope for swell there. And then finally, to the Indian Ocean. Little bit of a gale, 28-foot seas, pushing southeast. Maybe Tasmania will pick up some sideband energy from that. Now, here's this interesting tropical system. Again, 72 hours out. Don't know if I believe it, but watch it hug the coast of Western Australia here. And pretty intense in terms of sea heights in the 40-foot range, literally sweeping down the coast. If this happened, I think that would not be very good for coastal residents in this area. We'll have to watch and see how that plays out. Gale south of Australia, 35-foot seas forecast. Again, this looks like a Tasmania swell. And then we're out another local gale, 180 hours out south of southwestern Australia with 26 or 7-foot seas aimed to the northeast. So a bit more activity relative to the Indian Ocean and specifically Australia. Local wind forecast for California, Hawaii. Hawaii right here, California here. If you haven't read, Hawaii has been suffering, and the spots I've mainly been seeing have been on Oahu, but I think all the islands are affected by just torrential downpouring of rain. I know on the north shore of Oahu in the Haleiwa area, things have been pretty bad. You know, a lot of homes flooded. Just tremendous amounts of rain over the past 2 weeks falling, and it's still not quite over that yet. We'll get into it in a minute. But local wind forecast. All right, Southern California, there's the border with Baja, Point Conception under the tag there, Monterey Bay, that little indentation there, San Francisco Bay right there. High pressure pushing into the Pacific Northwest creates a pressure gradient, which generates winds 20 to 25 knots. This is on Sunday. Yeah, it was pretty much a chop mess. Again, this cutoff low pressure here north of the Hawaiian Islands, most of it was down here, and that was what was responsible for the bulk of the rainfall, but still there is more to come, hopefully not nearly as much as there was. We're into Monday. Winds lighten up along the California coast. Low pressure building. This is I'll call it the Hawaiian low, lifting off to the northeast. Some sort of a northeast wind scenario. 15 knots for the Hawaiian Islands. Northwest winds 15 knots for California. Tuesday, the low sets up. Wind event for the Oregon and Washington coast. 30 to 35 knots from the southwest. California, though, high and dry. Light wind regime. The Hawaiian Islands with trades at 15 plus knots. Wednesday, here comes the next high pressure. The Jetstream split out here. East-northeast winds, 15 knots for the Hawaiian Islands. Northwest winds, I'll call it 15 knots for California. But then as you get later in the day, here comes the next gradient. High pressure pushing inland. 25, 30, almost 35 knots from Point Conception northward. Trades 15 knots for the Hawaiian Islands. Thursday, here you go. The peak of the gradient, 35 knot winds from San Francisco, the whole way up to Cape Mendocino, and 20 to 30 knot northwest winds just off the coast south of San Francisco. So lots of wind swell, but a blown out mess. Probably another bout of upwelling along the coast. Trades 15 knots for the Hawaiian Islands. Friday, fortunately, the high quickly retreats. Light wind regime for California. Trades 10 knots or so for the Hawaiian Islands. Saturday, light wind regime for California. There's your building low. Trades 15 knots for the Hawaiian Islands. Sunday, relatively light winds for California. Trades 15 knots for the Hawaiian Islands. And there we are, 180 hours out. Low pressure filling the Gulf of Alaska. Hope it happens. I don't know that that's necessarily going to do anything for rain into California, much less the rest of the southwestern U.S., but at least it kind of looks like a spring pattern, if nothing else. Precipitation forecast. Hawaii, right under here. You see the plume of moisture feeding up into the low. That's on Sunday. Monday, you see it starting to break up. Still moisture, I'd say, from Oahu southward. Kind of hard to tell. Maybe that's Maui. But by Tuesday morning, a bit much more of a, I'll call it a normal rain pattern. The low pushing into the Pacific Northwest. California, there's the border right there, high and dry. Little bit of the front makes it into Cape Mendocino on Wednesday, and that's about it. Nothing else forecast. High pressure in control. Hawaiian Islands back into their normal kind of showery pattern, but nothing like what we've been going through. And then we continue with just high pressure in control of California. Another little bit of a front into Cape Mendocino late Sunday. We're 180 hours out, and that is it. So the bulk of California, nary a drop of water to be seen. Hawaii getting all of California's precip. The snow forecast dashboard for Olympic Valley, formerly Squaw Valley. You see nary a drop of snow to be seen. Same deal for Mammoth, not even going to go look. The freeze level here, this is the base of Palisades, Tahoe, 6,200 feet. This is the summit at about 9,000 feet, the top of the Palisades and Granite Chief. Red, if there were precipitation, it would be liquid precipitation. The freeze level right here between the gray and the white, that gray is sleet. So freeze level 12,500 feet into about the 26, and then, we'll call it 12,000 feet, slowly falling, but not until the very end of the model does the freeze level even reach the top 100 feet of the Palisades, and that's it. Don't even know if I believe it this far out. Still, it's a warm pattern, but remember last week when it was very warm, the reds were at 14,000 feet and above. So at least the temperatures maybe not be freezing, but they won't be boiling. Try to preserve as much of the snowpack as possible for as long as possible. Spot surf forecast for a couple locations. Let's start up there in Oregon, Columbia River area, west of Portland. Surf heights in the 5-foot range on Monday, building as the low impacts the coast on Tuesday into the 15-foot range, or 12-foot range, let's call it, but winds onshore at 20-plus knots. Then all that energy slowly fading. Notice the winds do go offshore, so for 3 to 4 foot surf after that with decent conditions for the latter part of the week. Swell heights, what do we get? 10 feet at 11 seconds. Yeah, pure wind swell. And then 0.9 feet at 16 seconds. That's okay, not a whole lot. And then 5 feet at 9 to 10 seconds and slowly fading out from there. Ocean Beach, San Francisco, pretty much nothing. Surf heights, 3 or 4 feet. This looks like it's wind impacted. You see the northwest winds, 20 knots, fading some, then up to 30 knots on Wednesday. That's a mess. Yes, and then finally some swell that's just wind swell, pure ugly wind swell. Winds just northwest the entire week. At least they're not 30 knots. They're back more in the normal range. Swell heights, pretty much nothing, 3 feet at 10 seconds. Rideable waves, you know where to go for that kind of thing. And then as we get into later in the week, 7 feet at 10 seconds, 3 feet at 9 to 10 seconds. You get the idea. Not a whole lot. Southern California, San Diego, just a whole lot of really nothing going on. Some sort of 2-foot energy. I assume most of this is probably northwest wind swell because up around the corner from Point Conception, winds are supposed to be nuking. Then fading out from there. Southern California, though, completely protected. Oh, here's a little bit of background southern hemiswell, 1.3 feet at 16 seconds. Then the wind swell sort of takes it over 2.5 feet at 11 seconds. But you get the general idea. I'll say actually the background southern hemiswell pattern starting, I'll say Wednesday and beyond. Not horrible for Southern California. Enjoyed. It might not be big enough, but it's a lot better than the just cold, windy, blown out mess that'll be north of Point Conception. The North Shore of Hawaii, not a whole lot going on. Buried under this somewhere there is some, little bits of energy coming from Japan. Trades, you see it here, 20 knots, pretty much the whole way through, if not more. Surf heights in the 3-foot range. Where's our swell? There we go, 2.5 at 13 seconds, 2.8 at 11 seconds. This is on Thursday, Friday sort of thing. Other than that, not a whole lot. Over to Ireland, central, just random locations, central Ireland coast, but a good proxy for generally what's going on. You see this onshore wind pattern, 30, 36 knots. Surf heights, 30 feet, but probably pretty blown out unless you have a nice protected little corner. After that, things kind of settle down, but then you see, look at these surf heights, 47 feet, 49 feet with 35 knots southwest winds, something like that. So lots of surf, lots of wind, very close to the fetch area. Kind of a little bit spicy, I guess you'd call it. Surf heights 22 feet at 12 seconds there on Wednesday. I'm just scanning. 15 feet at 16 seconds on Friday. And then where are we at? 28 to 30 feet at 16 seconds on Monday. Plenty of swell indeed. Takes the cake for the best or biggest spot on the planet. And the final stop, central Portugal. Surf heights in the 7-foot range starting Wednesday, 7 to 8 feet into Friday, kind of fading from there. Winds north, a little bit northeast here. In fact, east on Friday with 8-foot surf. Okay, there's a target. What do we have for swell-wise? 7.5 feet, 11 seconds. So you see basically all wind swell here. Theoretically, maybe some longer period swell off the end of the chart here, but we'll have to wait and see on that. All right, let's go take a look long term. We're going to examine the two major weather oscillations that affect the potential for surf over the planet. They are the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're going to start by discussing the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. They rotate around the planet west to east on the equator. Active phase on one side of the planet, inactive phase on the other, again, rotating around the planet opposite each other. The active phase is our friend. It is a low-pressure system. It takes warm, moist air at the ocean surface, lifts it aloft. That warm, moist air eventually hits the jet stream, feeding the jet stream energy, making it stronger. A stronger jet stream does not split like what we have over the Pacific. It consolidates, is more energetic, better at digging out troughs, supporting gale formation, exactly what's going on in the North Atlantic. The inactive phase of the jet stream is effectively a high-pressure system, falling air. That falling air steals energy from the jet stream, making the jet stream weaker. It splits and does all the weird stuff like what's happening in the North Pacific currently. We are going to examine what's going on in the Pacific for the moment. We are looking at data from the TAO buoy array, a series of buoys strung from east to west across the equator. This is the far west Pacific here. Here's the date line. Here's over by Ecuador. We're just on, this is the equator right here. So we're just examining 10 degrees north and south of the equator. Just looking at the arrows. These are the wind speeds. Wind speeds over the east equatorial Pacific, out of the east, moderately strong over the central Pacific, moderately strong over the date line. But what is this? Actual, not anomalies, westerly winds blowing over the western Pacific, the Kelvin wave generation area. This is very key to the title of our video. I'm not going to get into that quite yet, but westerly anomalies are a sign of perhaps the active phase of the MJO, and the active phases of the MJO is what ushers in El Nino. These westerly winds take warm water that's normally sequestered in the far west Pacific, if not in the maritime continent, and allow it to spill into the Pacific and then start tracking across the Pacific, not on the ocean surface, but down 150 meters, let's say 450 to 500 feet, in what's known as a Kelvin wave. That is a ball of warm water that's held by the Coriolis force to just a couple of degrees along the equator. That warm water eventually hits Ecuador, erupts to the ocean surface, starts forming a warm pool. Why am I talking about this? Because if you have successive active phases of the MJO, just like what we're seeing here, and that's pretty solid, then you can get successive Kelvin waves. Successive Kelvin waves is what ushers in El Nino, and El Nino is characterized by the transport of warm water from the West Pacific to the East Pacific and dramatic warming of surface water temperatures off of Ecuador and the Galapagos. That warming water creates evaporation, and it suggests a wholesale change in the circulation of the Pacific Ocean and the maritime continent. We'll get into that in a minute. Right now, we're talking the MJO. Okay, clearly, westerly anomalies suggest active phase of the MJO in the West Pacific. But it is not the average wind speeds, that's what means are, but the anomaly, the difference from normal for this time of year. In the far East Pacific, we see a little bit stronger than normal trades, easterly winds. Maybe that's creating some upwelling. Pretty much neutral over the entire Central Pacific. But here in the far West Pacific, we have pretty strong westerly anomalies set up, suggesting again active phase or something even more kind of good relative to California developing in the far West Pacific. Let's go see what's been going on for the past 5 days. Here are 850 millibar zonal wind anomalies. That's up about 4,700 feet, but are the trades blowing stronger than normal, or have they collapsed, or are out and out westerly anomalies the opposite of trades in control? Okay, so there's South America, Central America, New Guinea right there. 0 is the equator. Dateline is right here. And it's only 5 degrees north and south of the equator. You see all this, the red and the arrows, westerly anomalies, blues, easterly anomalies. This is all great, but it's not what matters if you're trying to transport warm water east. But over here, there's 5 degrees north, 5 degrees south. So right here and about as far the West Pacific as you can get, March 13th, we had westerly anomalies. That continued on the 14th, the 15th, the 16th, and if anything, building in coverage almost to the date line as of the 17th, and today's like the 22nd, so this is lagging a bit behind, but you get the general picture. Things looking pretty good here if you're trying to develop El Nino. So what is the forecast? And this is also a Hindcast too. GFS model, 850 millibar zonal wind anomalies. Same deal, all right, but this is the whole planet now. Okay, the date line runs right up the middle. Far West Pacific starts at 125 east, so like right there. The Kelvin wave generation area. If you want a Kelvin wave, and I think we do, then you have to have westerly anomalies between 125 east and 170 west. Any further west, like California's at 120 or 122, you have to have the westerly anomalies blowing over the West Pacific to get the water moving to the east and then have it fall and travel down the thermocline. And that area, the sweet spot where it falls down to the thermocline, is right here between 125 and 170 at the most. All right, now look at this. Starting somewhere February 25th, we had westerly anomalies. They kind of backed off, active phase of the MJO. And then starting March 8th, in earnest, those westerly anomalies built. The red here, somewhere, now not strong status. These colors up here would be really strong. This is sort of moderate plus westerly anomalies. But on March 8th, And I'm saying this, there's a bit of a tipping point that I think set up on March 8th, and that's key to the title of the video. What we were talking about, 3 months and counting sort of thing. All right, so westerly anomalies developed. They are continuing, filling the entire Kelvin wave generation area today, and our forecast for the next 2 weeks, filling again the entire Kelvin wave generation area. That in and of itself is like reason to get excited. I'm actually kind of surprised the Jetstream is not responding in kind, but it's not. I think a lot of that is because these westerly anomalies are not strong enough. They're not up here in like the pink shades. If they were, then you'd get dramatic response from the Jetstream. But what we have is sort of this steady push, and I think this is a hint of what the character of the coming El Nino is going to be like. Maybe not like fire and just like really, strong and oh my gosh, look at this, but maybe more this just steady pulsing kind of a pattern. We'll have to see. Now, the other thing key on this chart, notice easterly anomalies over the maritime continent right here. The pattern for the past couple of years has been easterly anomalies over the dateline. In fact, you can see it right there, the last bits of it, and westerly anomalies over the maritime continent on March 8th or so. Some switch flipped, at least it looks that way, and now easterly anomalies over the maritime continent, westerly anomalies over the Kelvin wave generation area. Very interesting. This is typically what happens when you're getting into El Nino territory. The whole pressure pattern shifts between the Pacific and the maritime continent. Let's dig a little deeper. Outgoing long wave radiation. Okay, what's that mean? It's just basically cloud cover. If you have the active phase of the MJO, which is low pressure, and it's taking warm, moist air and lifting it aloft, that warm, moist air eventually condenses in the upper reaches of the atmosphere, creating more clouds. Likewise, the inactive phase of the MJO, high pressure, is falling dry air, and that dry air exposes the ocean underneath it to a lot more sunlight. You get a lot more sunlight reflecting off the ocean surface. That's what this chart is. The blues mean less sunlight reflectivity, more clouds. The oranges and reds, more reflectivity, no clouds. So active phase and inactive phase there. South America, Central America, there's Hawaii up there, New Guinea there. EQ is the equator and the date line right there. Kelvin wave generation area from the far west Pacific, 125 east, out to 170 west, 5 degrees north and south of the equator. So according to this, the statistic model, active phase is in control. It shows 5 days, 10 days, 15 days from now, the active phase fading out, and the inactive phase building over the maritime continent, pushing into the west Pacific. That's one view of the world. The dynamic model, though, paints a different picture. It shows the active phase of the MJO. Again, not raging, just sort of like what we saw in the previous chart. This is the GEFS model, but a steady, moderate, active phase of the MJO on days 5, building some days 10, holding day 15, 2 weeks out, with the inactive phase locked over the maritime continent. Inactive phase, no clouds, falling air, high pressure. If the high pressure pattern has shifted, this inactive phase will sit stationary. The active phase will also sit stationary over the dateline. The statistic model isn't buying that and is thinking this is just a normal pattern, where the dynamic model, the GEFS model, I think is sensing something else is going on. Here's the phase diagrams for the same two models. Statistic model, dynamic model. Statistic model, how do you read this? The active phase moves west to east on the equator, from the Indian Ocean to the maritime continent, to the West Pacific to the East Pacific, under the United States, remember it's on the equator, over the Atlantic, over Africa, back to the Indian Ocean. This chart maps only the active phase. The inactive phase is basically, on the other side of the planet. All right, the heavy dot is where the active phase is. The closer the active phase is to this is the circle of death, the weaker the active phase is. So according to the statistic model, a very weak active phase, moving 1, 2, 3 different model or members, suggesting it moving into the far west Indian Ocean 2 weeks from now and split between very weak and modest. The GEFS model suggests some flavor of the same thing, but with the active phase hanging somewhere closer to Africa and moderate in strength. What's saying that? Oh, well, here's the active phase actually in the West Pacific right now, or almost the East Pacific. But we're looking at the charts and going, well, the active phase really looks like it's on the date line. The date line would be like right here, I would think, right about this area. So maybe what we're seeing with those westerly anomalies is somewhat related to the MJO, but maybe it's something all on its own as well. And what could that something be? So then we go to the CFS model. This goes out a month, this version of it, and it has the MJO, black contour here, all right? And it goes back in time. So dateline right up the middle. This is the whole planet on one chart again. 125 east, the far west Pacific there. You got it. Reds, westerly anomalies, the solid black contour, active phase of the MJO. So there was one active phase back there in December. We got a Kelvin wave from that. That has already impacted the Ecuador region. A second active phase developed in the January timeframe. It takes about 3 to 4 months so for the Kelvin wave to make it from the West Pacific to the East Pacific. So let's say end of December to end of January, end of February, end of March. That Kelvin wave, I think, is impacting Ecuador as we speak now. Inactive phase followed in February. Then here was the beginning of the active phase with westerly anomalies pushing over the far west Pacific. That was February. Well, actually, the beginnings of it was like, February 8th or something like that. And that did its thing. And then March 8th, westerly anomalies go, well, I'm going to redevelop again. And I'm going to camp out over the dateline. And I'm going to just hang there for the next 4 weeks, 1, 2, 3, 4, with a active contour perhaps setting up. And notice really, here's your pattern. Active, inactive, active. There's your inactive, and it should be in control out here, but the model is not showing it. What characterizes El Nino? The preponderance of the active phase of the MJO, or what appears to be the active phase, hanging over the date line, where the inactive phases in the Pacific almost disappear. That is what the model is hinting at here. Let's keep digging. All right, so here's the CFS model. Past performance here, the forecast out here, the date line 180 west, right up the middle, far west Pacific 125 east, right there. You can see this, those of you that watch every week, this is a glaring red signal. Now we won't get into the details right yet, but you see nothing but westerly anomalies for the next 3 months, if anything building as we get into June. All right, interesting. Notice how the pattern was before, blue, 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 blue. Here was our, where was our December active phase of the MJO? It was here. Here was our January active phase of the February active phase of the MJO, somewhere in there. And now here is the beginning of this wholesale wind pattern shift. Also notice the blues that were over the date line now setting up over the maritime continent. It looks like a pressure pattern shift has already happened, at least at the ocean's surface, if one is to believe this model. Now, last week, the big debate was massive reds up in here. Notice the model has backed off considerably on that. But what it is now suggesting, just this steady machine, this pulse of, I'll call them moderate westerly anomalies versus, just some insane sort of push and then nothing kind of thing. Again, speaking to potentially the character of this developing El Nino. All right. Let's overlay the MJO. Here we go. There we go. Active phase of the MJO, according to this, kind of like at its peak, if not fading, but lingering into about April 14th or 15th or so, and then east of the date line, with the dotted contour inactive phase setting up. But look at this, westerly anomalies forecast during the middle of a 3 contour inactive phase of the MJO in May. Interesting. So let's overlay, again, I talked about a wholesale change in the pressure pattern. All right, so the dotted contour is the high pressure bias, the La Nina signal, which has been in control over the date line. Notice the second contour today, actually yesterday, faded out. The final contour already pushing off to the east, and within the next week moving quickly, basically collapsing over the Pacific, while the low pressure bias, which has been, started about February 25th, started slowly easing to the east, deeper into the Kelvin wave generation area. About a week out from now, it's going to start moving quicker, and 2 weeks from now, it's just going to be on the rush, hitting the date line about a month from now. And that would explain all these westerly anomalies. Again, the wholesale pressure pattern change. The blues moving from the date line over the maritime continent, westerly anomalies from over the maritime continent over the date line. Those westerly anomalies mean that there is uplifting air, low pressure, that's going to build. You can see it. 1, 2, 3 contours over the date line as we get into the summer. This is very good. Now, when this happens, once you start with this, and I'm going to say it actually started on March 8th, about 3 months from that point in time is when you're going to start seeing some effects of that showing up in the jet stream and in the, at least the Pacific atmospheric circulation. That is the theory. So March 8th, to April, to May, to June 8th, June 10th, somewhere in there, that's when we should start to see potentially a change in the Pacific. Also notice that that kind of lines up with the spring unpredictability barrier, which starts like March and goes March, April, and May. Come the early part of June, then the models have a much better sense of what's going on. By the time the models come out of the spring unpredictability barrier, my sense is the pattern will be well established if one believes all this stuff. We only have about last week it was 2 to 3 weeks out. I'm going to say 2 to maybe even 1.5 weeks. I mean, once you start getting these moderate westerly anomalies setting up, then I think we're going to have a lot better handle on what this El Nino is going to do. All right, so let's focus on what's happening right now. Ground truth data. We're going to start by looking at trying to understand the movement of subsurface water temperatures, right? Again, we're looking at TAO buoy array. These buoys, here's the anchor lines on the buoys. This is the East Pacific. This is the West Pacific. There's X's are the sensors on the anchor lines. They're giving us real-time data about what's happening down in the ocean. The 30-degree isotherm is actually creeping a little bit east. I think it was at 166 last week. It's at 167 east this week. Last week, the 29-degree isotherm, about where it was last week. The 28-degree isotherm definitely on the move, though. It was at 176 or 175. Now it's at 174. And you see a thickening of the 24-degree. This is the actual isotherm right here. It was, it's about where it was last week, but over the past several weeks, it's now deeper than 25 meters. I'll call it 30 meters deep, something like that, suggesting warm water building above it, but not actual temperatures that matters. Again, it's the anomalies, difference from normal. Now, we see 4-degree anomalies. They're actually rebuilding here in the West Pacific, suggesting westerly anomalies are already dumping warmer water off the maritime continent into the far west Pacific. The Kelvin wave, I think this is a mixture of Kelvin waves number 1 and 2. 2 degrees centigrade, so what's that? That's like almost 6 degrees Fahrenheit above normal in the East Pacific. A little bit of a 1 degree break right in here. And it actually is breaking now, suggesting the 1 Kelvin wave, then things back off a little bit, another Kelvin wave, things back off, and that's what this is suggesting. Kelvin wave number 2 erupting, Kelvin wave number 3 building, and that pause in between. Let's go look at some other data. Okay, again, subsurface water temperature animation. This shows you literally, you can watch the Kelvin waves pushing across. There we go. Kelvin wave number 1 pushing across, erupting. Kelvin wave number 2 building, or maybe number 3. I think that it's hard to tell exactly to pull them apart, and you'll see why in a minute. But you see, now this one shows the break, but not nearly as pronounced. Was that 1, 2, 3, 4 contours, 1, 2, 3. So 1, 2, 3, 4. So 2 degree anomalies in the break here. The previous chart showed 1. I guess it depends where. In fact, we could probably go look where are the sensors. There are no sensors there. No wonder it's having a hard time figuring out what's going on. Anyway, you get the idea. Warm water building in the west. Kelvin waves, warm water pushing east. The thermocline, 150 meters down, you watch it spill off, travel along the thermocline, impact Ecuador, erupt to the surface. Here's the satellite data showing you the height of the ocean. You strip away the waves, the winds, the tides. Is the sphere of the ocean higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water, there we go, contracts. When it contracts, you end up with a little divot on the ocean surface. Warm water expands. When it expands, you'll end up with a bump or a positive anomaly in the ocean surface. That's what this chart measures. Equator, dateline, Chile, Peru, Ecuador, Galapagos, Central America, New Guinea there. You get the idea. Positive anomalies, 5, 10 centimeters, filling the West Pacific. Again, warm water spilling off the maritime continent into the thermocline, filling this area. Then tracking, notice it, just 3 degrees north and south of the equator, being held in place by the Coriolis force, impacting the Galapagos and Ecuador, and then spreading north and south down the coast. And this aerial coverage of this spread is significantly higher than it was even last week and the week before, suggesting Kelvin waves are in fact in flight. Upper ocean heat anomalies, same deal. East Pacific here, West Pacific here. This was last summer, 1, 2, and fall. Cold upwelling, La Nina in control, not that strong. I mean, on this chart you go, well, La Nina wasn't that strong, but you see what's going on over in the North Atlantic this winter and the total lack of surf in the North Pacific. And I think the oceanic signal does not accurately convey what's really happening in the atmosphere. Anyway, back in November, December, first active phase of the MJO, you see Kelvin wave number 1 traversing the Pacific. January, February, Kelvin wave number 2 pushing its way across. And so the real issue here is, well, let's see. Okay, if it was January to February to March to April, it really shouldn't be April till Kelvin wave number 2 impacts, say, Ecuador. So it's a mixture of both hitting here. And then here is March. Westerly anomalies, what was it, March 8th, I said, is when it started. You see the buildup again. There's the first Kelvin wave, the second Kelvin wave. Here comes the third building and looking every bit as solid as the second and likely even more so. Also notice warm anomalies not dissipating here in the far West Pacific. The amount of latent heat energy in the ocean there's a lot of it, and it's going to take more than 3 Kelvin waves to discharge it all. All right, now what's going on in the ocean surface? It is there where evaporation, warmer than normal waters start evaporating. That starts lifting air up. That lifting air then starts lowering atmospheric pressure. South America, Central America, New Guinea, the equator, the dateline. Kelvin waves 1 and 2 erupting here off of Ecuador and the Galapagos. We see the warm signature. We see it building out to almost 140 west. This is the remnant cool pool from La Nina, fading steadily. I mean, this white is dead neutral. Just the last little bits here. I keep thinking any week now all this is going to disappear, but it hadn't quite gone yet. The other thing is there's something going on here. We'll get to that in a second. But for right now, lots of warming off of Chile, lots even more warming off of Ecuador. You see the whole general pattern warmer than normal, but some of that too is the warming of our planet's oceans. These past 7 days sea surface temperature trend. Well, you see the warming here along Ecuador. Oh, I'm sorry, there's the equator date line right out there. But notice this. Cooling temperatures from the Galapagos sort of meandering the whole way along here. What is going on? Well, we do know there are easterly anomalies out here. We do know that westerly anomalies are here. I'm not quite sure where the dividing line is, but maybe somewhere about there. And my guess is what's happening on this dividing line, you have westerly anomalies going this way, easterly anomalies going this way. They converge, and where they converge, they lift, okay? And what that lift does is start creating stronger easterly anomalies. So you start getting mixing, if the winds are building, you start getting mixing and upwelling, if you will. Okay, and I think that's what's going on. But as these westerly anomalies build and start moving off to the east, I think this will tamp down, and we have Kelvin waves erupting here that'll start filling in warm temperatures in this area. So the short is, I think this cooling is just a temporary trend. We'll keep our eyes on that. The sea surface temperature trend in the Nino 1.2 region, the area right there by Ecuador and the Galapagos. Current values 1 and 277 thousandths of a degree above normal. Pretty much where it's been hovering since February 22nd or so. Be interesting to see if this continues to sort of work its way up. I think maybe it will be. This is not the official El Nino monitoring region, though. This is the Nino 3.4 region on the equator, 5 degrees north and south of the equator, from a spot south of California out to about the dateline. Current value, 287 thousandths of a degree below normal, so a quarter degree below normal. Normal is half a degree below to half a degree above. Now remember, this is not corrected data. They're not trying to get the global warming signal out of there. This is just pretty much raw data, okay? But from an El Nino or La Nina perspective, if you're half a degree to 1 degree below normal, that's weak La Nina. 1 degree to 1.5 degrees is moderate, and 1.5 degrees above is strong. Same deal off this way. To be strong El Nino, you have to be up 1.5 degrees or more. So we're still just hovering in the neutral territory, if you will. All right, what's going on in the atmosphere? Well, we're in the very early stages of this supposed El Nino development. Most of the effects at this point in time appear to be confined to the far west Pacific. But we are going to look at the Southern Oscillation Index, difference of pressure between Darwin, Australia over the maritime continent, Tahiti in the central to almost east Pacific at 140 west. Okay, when pressure is lower in Tahiti, the index goes negative. Well, it's at 4.02. Where have we been? We've been hovering around, pretty much around neutral for the past, since March 15th or so. Prior to that, strongly pretty positive, suggesting La Nina. 30-day average, this is your your active-inactive phase of the MJO indicator. 11.83 positive, inactive phase of the MJO. Pretty much 7.88, been holding there, if nothing else, even building a little bit. So this suggests still inactive phase of the MJO, but this is lagging 15 days behind. And again, Tahiti is in the Central Pacific. All the action is over in the West Pacific. 90-day average plus 10.03. Where were we a month ago? 5.27. So if anything, suggesting inactive phase. Let's go look at this on a graph. All right, so here's the 30-day average graphed out. This is the normal is considered +7 to -7. Where are we? Still up in La Nina territory, or at least inactive phase of the MJO. No big surprise, because again, most of the real activity has not hit Tahiti yet. So what are sea surface temperature forecasts supposed to do? Well, here you go. This is uncorrected data. Neutral, 0 right there. This is in the Nino 3.4 region from the CFS version 2 model. For the month of April, as when we get to April 15th, so we're still a bit out from now. In March, we were basically neutral. It says we should only be plus 1/4 of a degree. But then you get out into November and it says up to 2.3 degrees above normal. That'd be super El Nino status. And you see, I'm sure all of you have seen all the talking heads on news shows and articles screaming, super El Nino coming. This is what is driving that, okay? Again, it's a model going out 6 or 9 months or whatever, and really, we're just in the very early stages of this, so I'm not buying into the hype that Super El Nino is coming. This is the PDF corrected version of the model. It says temperatures getting to 1.7 or 1.75, which would be strong El Nino, which is kind of what it looks like, you know, just looking at the character of this El Nino. It's slow, steady, but plodding forward, like it will not be denied. Sort of like a slow-moving bulldozer, but not, you know, not a giant bulldozer or a medium bulldozer. And then we have the consensus model. It updated just a couple of days ago, showing you all the possible outcomes. The dark red is the whoop, can I get it? I don't know that I can. Anyway, you can see the dark red is the dynamic model consensus showing temperatures at about 1.5. The green is the statistic model showing just the weakest of weak El Ninos. Let's dig in real quick here. All right, so here is the average of the dynamic models. Where's the CFS model in all this? There it is right there. It's showing, in this version, 1.63 in September, October, November, all right? But you can look at the average of the dynamic models. It shows 1.528 in September, let's say October time frame, okay? This is probably a pretty conservative estimate. The statistic models only showing 3/4 of a degree above, 0.86, okay, out in, what is that, November, let's say December time frame. Okay, you take all the models, average them together, and they only show peak temperatures of 1.1 degrees, which would be a moderate El Nino, not even strong. So again, this caution around super El Nino, my hair's on fire. The one or two of the models suggest it. In fact, yeah, okay, the GAMO says 2.7 degrees. The COLA says 2.17, but most everything else is more like in the 1.5 degree range sort of thing. So take it all with a grain of salt. The key here is let's watch what's actually happening. So for right now, from a surf perspective, not a whole lot going on either north or south. Maybe a hint of a little bit of a gale developing a week out in the northern Gulf, but I don't buy any of that. Mainly wind swell is what looks to be the case. I mean, that's not unusual. March, April, that's typically the case north of Point Conception. Nuking north winds, upwelling, and kind of a mess. And if it being a La Nina year, sure, I grudgingly have to accept that that's what it is. If you're in Ireland, though, it's a continuation of what has been a good thing and just more of it happening. All that said, looking further out, it clearly seems that some sort of wholesale change is setting up in the Pacific, with the pressure pattern shift, higher pressure building over the maritime continent, lower pressure over the dateline, westerly anomalies setting up in the West Pacific, driving what is now 3 Kelvin waves, a 3rd Kelvin wave forming now as we speak. The magic is, what we say? The magic is 3 months out. Hang on, let me find it here. There we go. The magic is 3 months out, and that's what I'm sort of going with right now. 3 months from now, we'll be out of the spring unpredictability barrier. The warm water that is being generated or built into a Kelvin wave right now by a massive area of steady, solid westerly anomalies will start impacting Ecuador, changing the global weather pattern. I mean, we've already got warming waters. I think the global weather pattern, at least in the Pacific, is starting to shift. And 3 months out, we're going to see a bit more of a wholesale sense of that. And that will in turn inform us much more accurately about what the state of this El Nino will be. So I am not going hair on fire. I am not going full, oh, this is it. No, let's watch the data, let's follow the data, and use that data to make informed decisions and consider the fact that the spring unpredictability barrier is not favorable for the models. So the models can be on fire, but I'm not going to buy it quite yet. Let me know what you think, though. You all have perspectives that I sometimes miss. I get too far in the weeds. All right, that's our video for this week. If you enjoyed it, please give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question or an opinion, write it up down below. I'd be happy to read it, and I use your comments to help build the next week's video. And then finally, if you'd like to make a small contribution to the cause, you may. It is always appreciated. Use the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We will do it again next week, same time, same channel. Thanks so much for watching.